Okay, this review that I'm going to go over is with conditional probability. So the last one I talked about was compound, okay, which was your independent, dependent, mutually exclusive, or overlapping. Okay, so that's compound. Every time you see the word conditional, that's where you have your given statements. All right, so conditional probability, that is your given. Okay, so we talked about this on the homework that one day. So this is your given statements. Okay, now your formula for this, okay, is the probability of A and B divided by probability of B, however your problem is set up, okay, whatever you label your events to be, okay? So looking at number one, Tanya is selling 2 kinds of cookies, chocolate chip and sugar, all right? After going to 100 houses, she determines that 41% of people bought chocolate chip cookies and 38% of people bought chocolate chip and sugar cookies. What percentage of people bought sugar cookies given that they already purchased chocolate chip? So, I need to highlight some stuff, okay? So I have a given statement. So that given statement is separated by sugar cookies and chocolate chip cookies, okay? So I have sugar given chocolate chips. So I'm going to say this is, so A, oops. I'm going to say that A, where is this? Why is this working? I'm going to say A is my sugar. And I'm going to say that B is my chocolate chip, okay? So my formula should be the probability, so the probability of sugar and chocolate chip divided by the probability of chocolate chip, okay? So, probability of sugar and chocolate chip. Now, in the statement or in the problem, I told you the probability of getting sugar and chocolate chip, okay? Sugar and chocolate chip was right here, 38%, okay? Now, I'm not going to put 38 in my numerator. 38% as a probability is 0.38, okay? Now, the probability of chocolate chip, we already talked about that. That was another statement, okay? 41% of people just bought chocolate chip, okay? Now, 41% as a decimal is 0.41, okay? So, you are going to say 0.38 divided by 0.41 is 0.92. Okay, now, my question says what, oops, it says what percent. So I'm going to take my probability and I'm going to change it into a percent. So 92% of people, okay, bought sugar cookies given that they already purchased chocolate chip. Okay, so that's a little bit explanation. I'm going to go through the rest just a little bit quicker. Okay, so I'm going to highlight some stuff here. So the probability that they won both games is 31%. The probability that they win the first game is 71%. I need to find what the probability will be given the second game given that they already won the first game. So I know my numerator is my and statement. So my and probability is 0.31. because that comes from my 31% because they won both games, okay? And then the probability they just won the first game is 0.71. Okay, so 0.31 divided by 0.71 is about 0.44. Now it says what is the probability, so I'm going to leave my answer like that. What is the probability? Okay, so your numerator is always your and statements in your question, okay? Your numerator is always your one single probability that is named. So this is your single probability. Okay, it's usually your event B in your formula. All right, the next one. During a storm, the probability of the power and the cable going out. Okay, so probability of the power and cable going out is 31%. The probability that the cable will go out is 54%. All right, what is the probability that the power will go out given that the cable is already out? Okay, so my probability B is cable. So this is my B, so that's going to be my numerator. So the probability of my cable just going out is my 0.54. And my numerator, so both going out, is 0.31. So 0.31 divided by 0.54. So 0.57. So it says what is the probability, so I'm leaving my answer like that. Okay, number 4, so your and statement, it goes on the top. So 0.61 divided by 0.63. 0.61 divided by 0.63, about 0.97. Okay, and statement on top, event B on the bottom. Same thing with number 5, okay? Let's see, 2 flat tires, so both flat tires, so 0.13 over just 1 flat tire is 0.21. So 0.13 divided by 0.21 is about 6.62. Okay. Number 6, what is the probability of thunder or lightning during the summer? So thunder and lightning, so my both is on top. My one single just thunder is 0.27. So 0.19 divided by 0.27. About 7.7. Number 7, Matthew and Lexi decide to go out to dinner. The probability that they both order a hamburger is 7%. So that's 0.07. So 0.07 for both get a hamburger. The one of them orders a hamburger is 0.24. So 0.07 divided by 0.24. This is about 0.29 is your probability. All right, and then number 8, a pair of dice is rolled. What is the probability that the sum of the 2 dice will be greater than 9 if the first is rolled? Okay, so this one you're going to have to do a little bit more work. Okay, the probability that the sum of the 2 dice will be greater than 9. Okay, now this is like, okay, saying like you have a 1, a little bit more work. So you have 1 plus 1, 1 plus 2, 1 plus 3, 1 plus 4, 1 plus 5, 1 plus 6. Okay, now you can't do 2 plus 1 because 2 plus 1 is already here, so you can do 2 plus 3, 2 plus 4, 2 plus 5, 2 plus 6. All right, so those are your 1's first, 2's first, 3's first. So 3 times 1 you can't do, or 3 plus 1 you can't do it because it's already in your 1's column. You can't do 3 plus 1 because it's already, 3 plus 2 because it's already in your 2's column, so you can do 3 plus 3, 3 plus 4, 3 plus 5, 3 plus 6. Let's move on to 4. You can't do 4 plus 1 because it's here in the first one. You can't do 4 plus 2, it's already here. Can't do 4 plus 3, you gotta do 4 plus 4, 4 plus 5, 4 plus 6. Okay, can't do 5s. Well, now you gotta do 5s. So 5s is gonna be 5 plus 5 and 5 plus 6. And then 6 is just gonna be 6 plus 6. Okay, so those are all your total combinations that you can get when you add your 2 dice. Now, what is the probability that the sum of the two dice will be greater than 9? Okay, so you gotta find that probability. And that's gonna go in your numerator. So the probability greater than 9. So greater than 9 is going to be your 6 plus 6, 5 plus 6, 5 plus 5, 4 plus 6, 4 plus 5, and I think that's it. So out of, you have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. You have 20 possibilities. Okay, now the probability of you getting greater than 9, 1, 2, 3, 4, 5, is 5 out of 20. Okay. Or actually, hold on a second. Remember, it's your and statement. So you have to have so your numerator is probability of you roll greater than 9, and you have a number 6 in it. So you are not going to count the 4 plus 5. Okay, you're going to count 1, 2, 3, 4 out of 20 possibilities. Okay, and then the probability that you roll a 6, so you have 1. Let's make this different color. So you have 1, 2, 3, 4, 5, 6 out of 20. Okay. Now you're going to get your numerator. It's going to be 0.2. Your denominator is 0.3. So 0.2 divided by 0.3 is 0.666. We can round that to about 0.67. Okay? All right, so the second one is kind of the same thing. We're going to use the same sample size up top. A pair of dice is rolled. What is the probability that the sum of the two dice will be less than 5 if the second die is a 2? So remember, your numerator is that it's going to be less than 5, and because remember, numerator is our and statements, and that there is a 2 in our dice. Okay, and then our denominator is just rolling a 2. Okay, so back up to our sample size up here. I did all my addition. Okay, less than 5, so I can say, so less than 5 and it has a 2 in it. So this is less than 5 and has a 2. And that's it. Okay, so I'm going to say 1 out of 20 divided by, now just a 2, I have 1, 2, 3, 4, 5. That's it, 5 out of 20. So 1 out of 20 is 0.05, and 5 out of 20 is 0.25. So 0.05 divided by 0.25 is 0.2. So if I ask for percent, this would about be 20%, okay?